Hello, welcome everyone, everyone who's joined or everyone who's joining. So this is going to be a 1 hour going deeper into the software engineering track. I previously spoke earlier yesterday just on general interviewing guidelines. And just give me 1 second. So we talked about general interviewing guidelines. Now this particular stream is going to be about specifically the software engineering track. As part of preparing for the event, we have 4 multiple tracks and software engineering, design, data, and UX. So in parallel, those other 3 tracks are going on. If you have signed up for data or design or product management, then please join the interviewing guidelines for those tracks. This one will be very focused on just general software engineering. And so that's where I'll be focusing on. My name is Farah. I am a co-founder and chair of the board for Pakistan Women in Computing. I'm going to be spending the next hour sort of going over software engineering guidelines, taking questions. I will have, I'll be talking through some of this stuff, but I'm really hoping that we can cover a lot more questions in this session and kind of anything that you are not sure about in terms of when you actually have a live coding interview. So the agenda is very basic. I'll give you a general overview of what the interviewing process is going to look like. And then we'll do more of deep dives on engineering interviews. So I kind of went over this already, what the hiring process is. The on-site interview is something that happens once you've had the initial recruiter screen, you've passed that, you've gone through your technical phone screen, and now you're looking at being called on-site or through a video call to actually do your full day interviews. It can be anywhere from 4 to 6 to even more, depending on your seniority, the position that you're interviewing for. But generally between 4 to 6 interviews, 1 hour each, is how they're structured. And today we'll focus on this full interview loop mostly. So I think the one key thing is you want to make sure that you are not too focused on sort of just yourself or making a particular good impression. You really are focused on conveying the full, strength of your experience, how much you have learned or grown, what things that you've done very specifically. So, try to be as calm as you can. That's also very important because your interviewer wants to make sure that you are somebody who can handle curveballs during work, right? Who is going to stay calm under pressure. So definitely stay calm, make a personal connection, do some chit chat, learn a little bit about the person you're talking to as well. I talked about the second part, starting before you start to write any code at all. You clarify your assumptions, clarify expected input and output. This part is very, very important. And so what I would say is, here's an example, right? What do I mean by clarifying questions? So let's say somebody's, you have a question given to you, given a string, find the length of the longest substring with no more than k distinct characters. This is kind of a very general type of problem, the kind of problems that you'll see either on your phone screen or on your full interview loop for software engineering interviews. You'll get some combination of array or string or a data structure problem, right? And you'll be told you were given a certain input, find X. And so the thing when I say clarifying questions, here are some examples, right? You want to ask, okay, is the substring any string within the input string that is greater than, let's 0? So if the string is, ballet, for example, BALLET, is B a substring, or is only BALL ball a substring? So is it an actual English dictionary word, or is it kind of any word in there, right? So knowing that will change how you answer the question dramatically, right? Because, for example, if it's only words that are let's say ASCII characters, or are only part of the English dictionary, then you have a finite subset that then you can test against, right? In terms of input. You ask things about, here in the question, it doesn't tell you anything about what your expected output should be. It just says find the length, right? So what does that mean? Do you return the length as an integer? Do you output the length? Do you return also the actual substring itself, the characters? Or do you return a pointer to the first letter of the string? So it could be any one of those things, right? Depending on the calling function or depending on what you expect. It's definitely going to change. So be very clear about what the expected output is, and also be very clear about what do you have to return, when do you have to return it. Any number of questions then, and this last one is very important. So most interviewers are okay with this, but it's also still good to ask, because I keep going back to this part where I say, before starting to write, clarify, and walk through test cases. And walk through test cases, that's what I mean by, can I first write pseudocode and explain my solution? So what that means is for this problem, then you can say, okay, can I put an example of what the input would look like? Can I put an example of what the output would look like? Let's go a little bit deeper into this problem, right? Explaining your algo and logic, writing clear, elegant code, good naming conventions, and modular solutions. So I will stop sharing this screen, and I will pull up another screen where I can actually go through this. Bear with me 1 second. There we go. Right. And so here on this screen, you will see it's a platform called Educative, and it's something that there's somebody that we partner with as well at PWIC. But it's a really cool platform because it's built specifically just for interview prep. So I'm just going to use it because I think they explain the problem statement, how do you actually do the code, they explain the solution, and all of the pieces that you'd actually find useful in a real whiteboarding interview. So here's the, find the length of the longest substring in it with no more than 3 distinct characters. And this, the interviewer will most likely say, where k is some number. And so when I say, clarify, this would be one way of clarifying. So you can say, for example, if, let's take an input string that's ARAACI, and where k is 2. So in this case, the longest substring with no more than 2 distinct characters, if k is 2, is going to be of length 4. So I mean, visually, if you look at it, you can say it's ARAA, right? And so that is how they've come up with this. So, but your algorithm will actually do this for any string, right? So once you've kind of said, okay, this is one example, is this correct? Is this kind of what I'm expected to output? And this is how I'm supposed to solve this. And so you've not written any line of code, but you've sort of said like, okay, is this the input? Is this the expected output? Can I test it with different values of k, where k is 1, k is 2, k is 3? Does the algorithm still hold? And this part is very important because, if you don't do it with k equals to 3, for example, you might find out that, it's actually, not taking care of a certain edge case. So it's very important for you to use the whiteboard to actually write these things down and say, okay, this is how, I'm understanding this question. Repeat it back, write down. So this is almost, if you figure out how to do this here on the whiteboard logically, then now all you have to do is really convert it into code, right? The other part that is very useful is if once you do this with the question and you have it on one side of the whiteboard. So I always kind of methodically start in these interviews. Well, I'll use one side of the whiteboard, write down, assumptions, write down inputs, expected output, write down an example, right? So when I say tested with a test case, this is what I mean. This is the test case where k is 2. This is the input string. I went through it and I said output is 4, and this is my actual substring ARAA. And so that I've gone through 3 test cases. So now I know that my solution will work My solution works for different values of k. I've thought through some of the edge cases. Now I'm going to convert it into code. And then it's going to be much easier for you to actually take that and go and write it out in real code. Educative has a way for you to actually write the solution here and solve it yourself. So that's one thing I always recommend, right? When you're, practicing for software engineering interviews, you can read a lot, you can get a lot of guidelines, but basically there's no a real replacement for practice. There's no replacement for actually writing code. So when you get a question, even if, for example, you saw this question here, and you didn't really know how to solve it, you didn't have a good idea, try solving it first yourself. Because what happens is the mental process that you go through when you're trying to solve a problem, even if it's difficult, even if you don't know, that process is going to be something that, if you're actually able to crack it yourself, you won't forget how you arrived at the conclusion, versus many times you were not sure, then you go look at the solution, but when you have to try it again, you're not able to replicate the solution. So it is very important to first kind of give it a try yourself. And then this is a part where coding languages come in. So you'll be doing a lot of interviews, hopefully, during this fair. And I would say before going into it, be clear about what language you want to code in. So pick a language that you're most comfortable with. And if you've already talked to the team, or if you've looked at the job description and you know that they're expecting you to know Java, or they're expecting you to know Python, then use a language that they're expecting you to use. Otherwise, if they're open to you using whatever language, pick one that you are very comfortable with, because no matter how good you are at a particular programming language, when you're in a slightly stressful situation like an interview, you can forget. And so if you've been coding, let's say for 5 years in Java and only 1 year in Python, if you decide to go with Java, even if you kind of get nervous or forget something, your muscle memory will kick in, and you will remember something that you did from a previous project and exercise, and you'll be able to use it. So just make sure that you use something you're very comfortable with. It is the number one thing that comes across very clearly to the interviewer. And so you can't, again, fake that. And so what I want to go through here a little bit also in some detail is the solution, right? So there's many different ways to solve a problem. Here's one that they've described, right? In this particular way, you can sit down and sort of think through, all right, I will solve it using, this method, or I'll solve it using a hash map, like they've said. But the idea is that whatever your solution is, you should be able to explain it. Like, for example, if you say, if you're giving the solution to this problem and you're saying, this problem follows a sliding window pattern, and we can use a similar dynamic sliding window strategy. If you don't really understand what the sliding window strategy is enough to really be able to explain it, then I wouldn't mention that, right? Like, I would either go and try and understand it and explain it to myself, or I would try something that makes sense for me. Similarly with hash map, like I have people in interviews will come and we'll say we'll use a dictionary to do this, and then when you kind of try to dig into, like, do they understand how dictionaries work, or some other data structure, right, like a binary search tree or whatever, and if they don't really understand the fundamentals, it breaks down very quickly. So make sure that whatever you are proposing as a solution, that you understand all the data structures that are involved with it. And so it's a very good explanation of this problem, actually. You're talking about using a hash map to remember the frequency, right? So how many times each character was processed. And so what they're basically saying here is, we'll insert the characters from the beginning of the string until they get to whatever. K was 2, so they get to 2 distinct characters, or K was 3, they get to 3 distinct characters in the hash map. And then they keep adding each character in the sliding window in a stepwise fashion. In each step, they try to shrink the window from the beginning if the count of the distinct characters in the map is larger than K, right? And while shrinking, then they decrement the frequency of the character going out of the window. So that's the general, I would say, they've said, okay, here's my general framework for solving this problem, right? And then at the end of each step, they check if the current window length is the longest. So this is the algorithm, right? And now your job is not just to write it in code. You should be able to explain as you're writing the code to do this. You should be able to explain each step as they're talking through. And I believe here's how they're, yep. So they have, for example, this code in Java. You're writing this, you're actually going through the pseudocode, explaining it, and then you're actually writing the code here. The thing about now switching to sort of best practices when you're kind of writing your code, you have to make sure that your naming is very clear. Your variable naming, your method naming. So longest substring k distinct, right? Very clear what this is about. You almost didn't need to read the exact problem to know what this question is solving, right? Because they are very clearly stating that they're using the sliding window strategy. They've got the window start as an algorithm. So when you look at this, then you can, for people who are familiar with the strategy, they can say, oh, it looks like they're using a sliding window strategy here. When they are looking at counting character frequency, for example, and using a hash map, you can see that character frequency map. It's a very relevant naming. So those are the kind of things that you have to be very clear about. I also see candidates go through and put comments during the code. This is really just a great way for you to show that you really and truly understand what you're doing. This is something that you don't go overboard with, but this strategy can be very helpful when you're trying to, like, for example, this part here, right? It says shrink the window. So when you're actually going to go through the example, through your code with an example, then you can very easily say, oh, this is shrinking the sliding window at this point while we're left with k characters, and this actually shrinks the window, right? Another way, another good strategy for using comments is you would actually like if you want to come back to doing test cases or edge cases, then sometimes candidates will start this, and then, like, for example, if they're not doing this part right, they're not checking for illegal arguments, or they're not checking for basically that the string is not null. So they may just put a comment here saying, we'll check for null or length 0 or length less than k, and to do, right? So that you're showing that you've thought through, that that you have to check for these cases, that you do think in a very test driven development method. But if you don't have enough time to finish the problem, to go back and do that, then that's okay. At least you've shown that you would have done it, right? So a lot of candidates do this because they want to just focus most of their time on this main part, right? On getting their algorithm right. And then if you aren't sure, for example, that there's going to be a loop whenever you have any type of an input, that's a input string, input array, you're going to go through all of the characters, going to have some loop that goes through. So there, that you're going to have a for loop somewhere or a while loop somewhere. And if you're not sure of these exact, what the stopping condition should be, for example, right? Because some people just sort of get thrown by, is it going to be length or length minus 1? Just kind of array size limitation things. Something that I usually always used to happen to me when you are, especially when you are going back and forth from different languages. In some languages, in like C++, you have to do -1. In Java, you don't. You again, it's okay to sort of say, let's write some pseudocode first and say for, starting from the 0th element of the window all the way to the length of the string, right? Basically, the other interesting thing that this candidate has done is, or person coming up with the solution, is they are also testing this method out. So they've got their main function, where they're actually calling the method with a value of k, 1, 2, and 3, and the strings above, so that they can actually test that it's going to return the outputs that they said. And so this is the equivalent of, when you're doing the whiteboard interview, this is not something you have to do. But what you should do is, once you've kind of written this code, then you take these inputs that you were testing with and say, okay, now I'm going to test this code with, my input string this and k equals 2, and then let's make sure that it actually returns what I think it should return. So yeah, so it's a lot to take in, but essentially my main advice there is, you have to get good at doing these coding interviews. You just have to practice, and you have to practice a pretty wide range of problems. Kind of going into what areas you could focus on for these whiteboarding type interviews. It's pretty important to really go through your data structures and algorithms, because usually you only have like 1 hour. They're not going to give you very complex problems. So the data set on which they can ask you problems is very limited for that 1 hour, right? So they're going to ask you should do all your search algorithms, sorting algorithms, trees, know how to manipulate arrays, strings, like the back of your hand. Know what a trie structure is. Know what hash tables and hash maps are. Just make a list of, in fact, take the best data structures and algorithms book that you've ever read in class or somebody recommends. And that's probably the best way. Like, spend a few hours every day going through that, refreshing your concepts. Because, for example, linked list, right? Linked list is not a data structure that you use on a day-to-day basis usually. And so when you did it in school, you may not remember, right? And I get a lot of these questions. Well, I don't really need to know linked lists in my work. The point is that it's about what can we test in that 1 hour, right? And so it's easy to ask somebody a question around, let's say, a linked list, and really understand, like, do they know pointers? Do they get how memory works? Do they understand space-time complexity, right? It's a very easy way to test their understanding of their concepts, less so about that particular data structure itself, right? And so it's very, very important for you to be crisp in your data structures and algorithms for software engineering interviews. That would be the most important part. So there's a question here: is it better to do dry runs or test it the way candidate has tested above? Not exactly sure what you mean, but if you're asking whether to actually test the code, like writing a main function and testing it, it depends. When I'm going through this example, I'm thinking that you are in some sort of a face-to-face environment with your interviewer, or even if you're doing it remote, that you're both sharing a Google Doc or Collab Edit or something, so that you don't actually have a compiler. You're actually writing your code on some whiteboard, right? And so if you don't have a compiler, it doesn't really make sense to have a main function, really, right? Unless the interviewer specifically says, can you show me how this function will be called? And can you show me, what inputs you will use? So in that case, I would say yes, you would do a dry run manually using an example. The other benefit of doing a dry run manually using an example is that gives you the best opportunity to showcase your understanding, right? So whereas, for example, doing it this way, it's like, okay, fine. So you know how to write a main function and you know how to call something, right? But if you're actually going through and saying, okay, so I picked this string, and the reason I picked, ARACI is, we discussed, and you said it didn't really have to be an actual valid, English dictionary word. So I picked any, string, contiguous strings, and I'm taking k as 2, and then this is how I'm going to run it. And you get to actually walk through and say what this while does and what this left jar does, right? Whereas when you're calling it to the main function, you can't explain everything. So it gives you a chance to really shine if you're doing it manually. In my experience, like in my interviews, every time I've done it, I've always done it manually. And I've used that opportunity to also highlight and I think this could also be solved by using a binary search tree, and this is how I would have done it. So I use it to also show them that I can think of multiple ways of doing something. So yeah. um, so just to kind of recap, clarify, assumptions. Always write down. Start with one side of the board. Write down what your assumptions are. Write down what you think after clarifying the expected input, the expected output. Then always test with an example. So put an example, like here's an example input. With this input, is this the expected output you would expect? And then write either pseudocode or just English or whatever, and say like, this is how I think it would run. Once you've had that conversation with your interviewer who said, okay, this looks good, then you start on the other side of your whiteboard and actually start converting into code. When you're writing in the code part, it's best, in my experience, to focus on the hardest part of the problem. And so it's good to think through edge cases and all of that, but start by being very clear of what you're going to name your method, what it's going to return. Use clear naming conventions. And then if you don't have time to do all the error checking and you focus on the big one, you can always put a comment and say to do check edge cases, check for null, check for zero length. Do the meat of your problem and then go back and then run through it without an example. Just run through it and say, okay, I should do these error checkings, I should do all of this other stuff, comment it, and then run through it with a manual example. Then you've been very, very thorough. What that also will do is when you run through it again and again, you will figure out, oh, actually I could have optimized this here, or I could have done this small optimization here. So you're constantly showing the interviewer that you are you know how to debug your code, you know how to look at your code, you know how to make changes in real time, right? So once you're done with explaining it with an example, then the next piece is you should talk about the time complexity. Now, this is one area where I've seen with time and space complexity, a lot of candidates don't do it. And what I've realized is a lot of candidates don't understand what time and space complexity is. So I don't know if this is because you guys are not doing it in your curriculums, but this was something that I absolutely always expect every candidate to know. And so make sure that you, like I said, spend time doing data structures and algorithms work. Also spend some time really understanding what is space and time complexity, right? So in this case, for example, the time complexity of the above algorithm will be order of n, where n is the number of characters in the input string. The outer for loop, which is this one, right? It runs for the length of the string. And the inner while loop processes each character only once, right? Therefore, the complexity will be order n plus n, which is really just n. And this part, while you're reading it, you can explain it. Know what order n means. Know that, like for example, you may have solved a problem where you're getting the time complexity is coming out to be order of log n, and or n log n, let's say. And your interviewer says, okay, can you optimize this? Or when it's order of n, if your interviewer says, can you optimize this? You're like, no, this is pretty good, or if it's n squared, can you optimize it? So you should be able to explain like when something can be done in constant time, or when something is exponential, what that means, what order n actually means. Similarly for space, right? If you're talking about the data structure, you should know how this data structure is actually stored in memory, how many characters will go into the hash map, and so is the space complexity going to be order of k? So do spend a lot of time just reading up and truly understanding time and space complexity, because that's if you can explain it well, that's going to make you a standout candidate as well. So this was just sort of going through more of the typical type of questions. Here you can see they've called this out as medium difficulty. And I would agree. In terms of the type of problems that you see, this is something that you could get in a phone screen even, because this is something that you can easily solve remotely. You don't need to be in the same room to ask too many clarifying questions. Versus a hard problem could be, if I say, if you had to design, how do you do real time tweets in something like Twitter? That doing that over remotely and doing that um, so exactly is not possible, right? Because it's a more of a general design, a high level design, and there's a lot of conversation there. So that is a candidate. That is a category of questions that I would say is hard, and they're more design questions than coding questions. So there can be different variations of this particular question, which could then go into between easy to medium. So take a look at educative lead code. I think is like really really great as well. You can just every day spend a couple of hours going there and actually practicing the solutions. And that's one piece that I would definitely want to highlight is writing actual code. Like there's a huge difference between me reading someone's code and me actually writing it down. So start a project. What I always used to do when I was prepping for coding interviews is I would start like my own solution, whatever ID you use is fine, and I would make like separate projects for each problem that I was solving. I would actually write the code. I would actually compile it. I would try to make sure that it's bug free. It really helped give me more confidence, so that I was less intimidated by having to write that same thing on a whiteboard, because you get so used to, especially with some of the other modern IDEs, you get very used to autocomplete, and you don't have to sometimes even think of what utilities you need to import, or like LinkedIn linked list exists for you, so you're never going to write your own class, right? So those kind of things, like if you're going to actually write classes for certain data structures, really always use an IDE and test it out that way. Unless you're really confident, which is great, then then you need to not focus on you're writing your code as much, but focus on how you explain it and how do you shine, how do you show that you can solve it in multiple ways and not just one way. So I will switch back now to my slides. I wish this was more seamless, but it's not. Here is my slides. So we kind of went over, making a good first impression, making good personal connection, clarifying your assumptions, walking through test cases, explaining your algo and logic, writing clear, elegant code. Don't try fancy shortcuts. Brute force is fine for first run. If you know the optimal solution, like so, sometimes people will know, and they ask me like, do I just sort of pretend and do the brute force really quickly and then do the optimal? um, I think that it's always good to show that you have a good methodical way of solving a problem. But if you really know how to do it in a much more optimized way, I think as you're writing your code, you can talk through it and say, I would just run a for loop twice to do this, but I actually think that I can do this with one for loop. So this is how I'm going to optimize it. So instead of it being a nested for loop and being order n square, now it's going to be order n, because I don't think that we need this other for loop for this reason, right? So it's what you're doing there is you're saying that I know how to solve this, like just with your basic brute force, but because I've taught it, and as I'm thinking about it, I'm already sort of being able to come up to optimizations. I'm going to write that optimized code first. This don't try fancy shortcuts. I am really saying this for folks who get kind of thrown by a question, or people who think that they have to really impress the interviewer off the bat by having like this perfect best solution. You don't have to. I think again, what's more important is that you are making it very clear that what you're doing and saying, you actually know what it means and you can explain it and you understand it. Good naming conventions and modular solutions. We looked into the naming conventions, modular solutions. So it really depends on the type of question. Like the question we just saw, there really was one method, but like for example, there's a question similar to that where you have to manipulate, let's say, strings or arrays. And as part of the question, there's the one of the constraints is that you have to all the characters, input characters, have to be lowercase when you're manipulating them. So not everyone would input lowercase characters, and you would want to convert them all. So one way to make sure that it's modular is instead of writing it in your case substring function, you actually call a convert lowercase or return lowercase, and you can call that method within this one, and then you can show that, okay, I've got this modular method. And that's the kind of thing what I mean by modular solutions, because let's say the question changes a little bit and they say, okay, no, everything should be all uppercase. Then you can just make a slight modification in your called method, but you don't actually have to change your main method. So just whenever possible, be able to show that you can think in logical pieces, and then you can connect the pieces together. And that you are not somebody who can only think of monolithic solutions, right? And this is very important for when you're working in a team and you're working as a group. You can have different people working on different parts of the solution, right? Otherwise, having a monolith solution can mean that it's very hard for anybody else to contribute to it. And you've not made it very easy to maintain. You've not made it very easy to support. So only you can figure it out. And that's generally a huge, it's not beneficial to the team, right? You're not helping because you're not able to build something in a way that a team can work on, right? So the throughput, the productivity, if 3 people were working on a piece that was modular, now you've sort of made it like only 1 person can do it. And for maintenance, and it's generally just bad coding practice, right? And then this last piece is, then at the end, always review your solution, run through it with a test problem, and then optimize where you can, right? If you're going through time, space, complexity, and you are like, oh, okay, maybe I can optimize it more, you can go back to the problem and do it. But keep the conversation going, keep it very conversational. That's going to be very helpful throughout for you, because the interviewer will always know what you're thinking and how you're approaching the problem. So I talked about this. I got some tips for on-site full loops. Again, I'm going to be ad nauseum repeat myself, but ask clarifying questions is probably the most important one. Repeat back the question. Whatever the question is that you're asked, repeat it back. Make sure to say, is this what you meant? Is this the question that you asked? Talk through your solutions. You're showcasing your problem solving and analytical thinking skills. You're showing that you can think of problems in a very methodical way. That's very important for the interviewer to see. Show that you can understand the bigger picture. So I talked about this yesterday a little bit. So this is more, if you're given a problem that is, let's say, a design problem, right? I think it's very important for you to be able to talk through the design in ways that shows the interviewer that I can see this being applied to in a very distributed system, right? It's not just code or a solution that runs in my machine under my desk. This is something that is going to be out there in the real world, and millions of transactions are going to come through it. Millions of people are going to be sending queries to the system. So it's not just a search that I'm doing locally, right? And it sounds very, of course, right, obvious when I say it, but that's one thing that I've seen a lot of interviewees trip up on, is they're thinking of the solution very much in like, and especially new college grads, right? I'm doing this for a project. It's running on my machine. They're not thinking about, this is something you're going to be working in a company. They build products for many, many people. You have to think about multiple people using your product and how they would use it, and what a search could look like if it's, millions of queries versus, you testing locally. So being able to show that you understand that, and being able to show how your design fits into the big picture. I gave an example yesterday, which I can repeat here, which is for like a data science machine learning position, I've asked this question. How do you determine that an item is going to be delivered in 4 business days or less, right? And it's a search question, especially on the e-commerce side. And people will come and they'll talk about, oh, you can use, you can start with linear regression, or then you can go into decision trees if you have this other data, if you're also looking at their cost, for example, right? So you want the best cost and the best time. And then they go through a whole slew of like, here's this algorithm, here's a hybrid model, here's how I would do precision recall accuracy. But the one that always stands out to me is the person that says, what's important is that, this brings in more traffic and more revenue through search. So if we combine this with another aspect, which is, the cost, if it's free delivery and it's, fast, then we can have a lot more people finding this on search. So how about we use this as a way to, surface something higher on search? And that would be a good way of incorporating this into our e-commerce product, right? So the kind of person who can think like that and make those connections, it's quite rare to have somebody really make those connections. If you are able to get a sense of the bigger picture and you're having that conversation, please make sure that you are able to put that across. Culture and team fit. It may look like your interview is all technical, but believe me, you're being looked at from a culture and team fit throughout. And there are many ways to do that, right? They are looking at, like, so for example, you're trying to solve it a certain way, and then the interviewer says, okay, I think that's a good way to solve this, but I think that instead of using like a hash table here, why don't you try using some sort of a binary search tree? And you think that the hash table is the right solution here, or you're not able to sort of change your thinking and go to this next sort of iteration of it. So some candidates will just kind of shut down, not know what to do. Some will get very combative and sort of start arguing. So these are all ways that the interviewer is saying, oh, this person is probably not going to be a flexible employee. This person is probably not going to be good at taking feedback or growing. So it's just a contrived example, but you can think of many ways where the interviewer is looking at you and how you're solving a problem, and also thinking about, oh, is this the way that this person thinks and collaborates or not? Does that make this person good for our culture and our team? So that's something that's always ongoing. In fact, even your recruiter screen, don't let your guard down. Every conversation that you're having with somebody at the company, you're in interview mode. They're evaluating you. And so be very careful. Don't you could obviously always share your personal opinion, but don't share anything controversial. Don't give opinions about things that you're not asked about, right? Try to keep as to the point as you can. And this handling feedback without getting defensive is kind of part of that. This last part about if you're stuck, so this can happen to the best of us, right? We're just having an off day. Some interviewers ask us a question and we just sort of freeze. We just don't know what to do. Like, we have zero idea how to solve it. Go back to these tips, right? If you even if you think of it as like, okay, you're buying time, right? So if you say, all right, so this was your question, is this what you were asking? Okay, what do you expect in terms of input? What do you think the input is going to look like? Like, if you ask all those questions, A, you're buying yourself some more thinking time, and B, some of those things may actually help you gear you towards a problem, towards a solution. So stay calm, don't panic, because the worst thing you can do is panic and show that when life throws you a curveball, you don't know what to do. You also don't want to give up. You don't want to say, I don't know, because there are many times we're faced with stuff at work where we don't know. The goal is not to just sort of sit back and say, I don't know, somebody else figure it out. What you want to showcase is that, all right, this is a difficult problem, but I have all of these tools in my belt that help me come up with a framework when I want to solve a problem that's difficult. And so I'll use those tools, right? And I'll keep using those tools till I get somewhere. Maybe I won't solve the problem, but I'll solve some part of it. I'll get to some conclusion. So keep thinking aloud, keep sharing your ideas, keep listening for hints, because the interviewer really wants you to do well. If they think that, like, for example, I'll just give you a human example, right? You have a human being interviewing a human being. If I like you, I've already seen your resume, I like your experience. If I'm having a good rapport with you and I'm like, oh, this person is so fun to talk to, they're doing a great job on the whiteboard, sounds like somebody would be a fun person to have on the team, right? So if you're in that position, the interviewer is in their mind rooting for you. They don't want you to fail. They just want to make sure that you're going to succeed at the job. And so they are going to try their best to help you as much as they can where it makes sense. So do always enter with that mindset that the interviewer is there as your partner in this journey, and that you are going to work with them to arrive at whatever conclusion, right? Um, and the reason I sort of say this, I see a lot of people freak themselves out before an interview because they're going in with this assumption that, these people are already biased against me, or they're not going to like me, or they're just going to give me a no hire because, they just keep going to try to stump me with harder and harder problems and give me a no hire. That's not how it works. That's not why they're giving their time. They're asking you harder and harder problems because they want to see how you react in a challenging situation, and they want to see how much they can push you, right? What's your upper limit? Because that helps them to even say, oh, how much more can this person grow? Should they come in? Maybe somebody is getting really, really complex questions. They're a new college grad, and sometimes it's because they're doing so well that they actually are above the bar for an entry level candidate. So maybe what the interviewer is trying to do is say, oh, maybe we should hire them as a software engineer too, because they're kind of already there and they have this room to grow. So that's really what sometimes the interviewers are trying to do. I put some general tips in here, which are mostly a repeat of the previous few slides. But I think the only important thing here really again is that I haven't talked about before is research the company, research the position, and always be ready with good questions, right? So if you're looking at this 1 hour interview, let's say the first 10 minutes are some sort of icebreaker. They ask you about your previous job. They ask you about previous projects. Then think about 30 minutes of coding questions, right? Whiteboarding and whatever, right? So, or it could even be 40, depending. So let's say you have 40 minutes, you've done 10 minutes that, and then at the last you have 10 more minutes. That's when interviewer is looking at you to ask questions about them, about the team, about the company. And so do as much research as you can beforehand about the team, about the company. If you know who's going to interview you, look them up on LinkedIn, look at what they've done, ask them interesting questions about their background, ask them relevant questions about the team and the job. That's another way that you can show your passion, that you really have done your homework because you're really excited about the opportunity. And if your genuine curiosity is just going to come through, and that's going to that's just going to be something that makes them think you're a great fit, right, for the team and the job. So this last part is really about what I try to communicate to a lot of folks is whiteboarding is really not about coding. A lot of people think that that's what it is. We know you can code. We know you can code because you've done a CS degree and you've done a lot of projects, and there's a lot of people in the world who can code. But can you explain? Do you know how to solve problems using code, or can you only solve the problems that you did in your very limited context in a school project or in an assignment, right? Can you use code to solve new problems that you've never seen before? Can you use your understanding of code and data structures and algorithms to solve completely new problems that no one has solved, right? And can you explain when you use it to actually solve a problem? Can you actually explain what you did so that other people can understand and then use that to solve further problems? So it's really about that. It's about how you think, how you approach solving a problem. That is what is really the goal of these interviews. The goal is not to trip you up. The goal is not to make you, write all kinds of fancy code on a whiteboard without some sort of an IDE and see how you do stuff without a compiler. It's expected that you will have certain bugs, right? Like it'll be expected that you forgot to put a semicolon, because we know that when you're writing code in a compiler, the compiler will tell you that the semicolon is missing and you can fix it, right? So what we're trying to just see is, does this person understand good syntax, right? Does this person understand variables and loops and naming conventions? So how much experience does this person have solving problems using code? So that's really what it's about. We have about, I think, 10 more minutes, but I'm out of slides. So, unless there are more questions, I can keep going on. But at this point, I'd love it if there are any questions. I'd be happy to answer them. So I don't see any questions. I also had a video that I was thinking I can share. I'm going to try and share it to see if it comes through. It wasn't coming through before. Let me share it. Let me know if you see it. And this is an example. I just kind of went to YouTube and found an example of a mock interview. So let me see. Yes, that's right. So the voice might not come through. I'll share these links in Slack so you guys can go in and check them out yourself. But here basically are a Google and a Microsoft employee, and they're actually going through a live whiteboarding exercise. And I think that this is the kind of stuff that would be very, very useful for people who've not especially gone through one of these type of interviews to actually see what this
and numbers of pi or digits of pi. And then I'm going to give you a list of numbers that are sort of like my favorite numbers.
And so the sound may not come through, so I'll kind of talk through it. So he's basically, here. Let me pop it full screen. That doesn't help. So here, this person is trying to go through and explain, how
be found in my favorite list of numbers. And so I'm going to give you a sample input and that output.
And this is kind of what you can expect to see in a screen.
Imagine I give you
in this type of interview. You'll have this kind of big white screen, and here he's asking him, okay, you have the sample input and this is the sample output. The interviewer on this side, they can actually see the code being written real time, and then the interviewer on this side is writing the code, and you can see who's actually writing at that time because it's real time happening. So this is most likely for most of you, this is what the experience is going to look like, where you're going to be actually going through the mock, or going through the actual phone screen or the full interview loop in some sort of virtual way, right? So I'm going to stop this because I really don't know if this is coming through as well. Oh, okay, perfect. The audio is fine.
List of favorite numbers. Does that make sense?
How does 793 is occurring over here?
793.
So I'm not going to go through the whole thing, but I'll post it. So what you see is the candidate keeps asking relevant questions. The candidate keeps asking for more and more clarification so that they understand the problem. The candidate is putting in some checks here based on the conversation that, okay, I need to check, is it zero-based indexing, and if it is, then do I minus from the length or whatever. And then this is kind of where they're saying, iterate on every prefix. So this is when I say pseudocode, this is what I mean. So you start writing down, okay, I'm going to...
let's say as pause till j, right? So let's say this.
So that's going to be very, very useful.
Exists in your array, favorite array. So if that happens, what we can do is basically we have the choice to make a space over here. So we do one space, which is one space, and then for the remaining we simply call check j plus 1, right?
Right.
And we just need to ensure that check j plus 1 does not return minus 1.
Right. So as you can see, you'll go through it. If you see a few of these, you'll get a good sense of what you should be doing. And what I would say is similarly, if you're able to sign up for one of the mock interview workshops, great. But if you weren't, get your, have a friend kind of do this with you, or get together as a group, and work on these problems together. But really, do this where you have simulate a mock interview scenario where your friend is treating you just like you're a candidate. asks you a question that you haven't seen before, and then you go through and try to explain it, right? And then your friend can give you feedback like, I think you were looking very nervous. This is what you can do to at least appear not nervous. You didn't check for error conditions, or there were these bugs in your code, and I kept trying to point it out, but you really didn't weren't getting the hint. So a lot of that stuff will help you, and then you can do several of these and refine your process. But personally, for me, that has been the thing that has helped the most, right? And as you see, a lot of what this person was doing, he went, he said what's the sample input output, this check position, this suffix, where this part that he's writing, this is the um, pseudocode or the algorithm. And once he's gone through this and he's talking throughout, right? So the one thing in the video you'll see, I'm going to keep quiet, I'll turn it on. You can see he's talking throughout and really trying to explain what he's doing.
We can pass in as arguments also. So basically, this check function would need access to the spy and favorite.
Right. Hey, well, you can use the global variables for now if you want.
Yeah, sure. Thanks. So basically, let's say they are right over here in the global namespace. All right. I think now let's say we already have them initialized with the values that we wanted, right? So this check function can do something like this. If pos is basically n, we can simply return 0, handling the base case. And then otherwise what we can do is for in j equals pos j is less than n, and then j plus plus, we can do something like cool, string cur is empty right now. We can do, so I'm building the prefix.
Yeah, cur is the prefix.
Right. So I'm basically iterating on all the prefixes possible. And if exists.
So you can see, I'll keep this going in the background. I'll turn off their audio, but as you can see, he's these are people who are already at these big companies, right, at Microsoft and Google, and this is how they're like. He's clearly, and the candidate has not heard this question before. He's trying to understand. He's thinking about, oh, if I use is there some sort of recursion happening here? Should I call this out as my base case? Should I call out my stopping condition? Right? He's thinking through, but some of the things that I really like about how he's approaching it is, he went through, he clarified, he tested with some test cases, he wrote the algorithm in pseudocode and made sure that what he was thinking makes sense. And now he's trying to write the code, and it's not like he's got the whole thing figured out and he's writing it step by step, right? You can see there's a lot of trial and error. He's talking throughout it, right? And he's thinking, oh, I should do this, but then as he's writing it, he's like, oh, that's probably not the best way to do it. Let me, go back. And that's really how it's going to be. And that's when I say keep communicating, be very clear, is because you're going to be working. You can see that the interviewer is either saying yes or no, or working with him. That's what a real life whiteboarding interview situation is going to be like. You're going to be working on it together, except it won't be pair programming because he's also not solving the problem, but he's sort of there nudging you along, making sure that or if you're going too much in the opposite direction, then they'll get you back on track. So that's really how it will be. There's a lot of these type of whiteboarding interview videos. There's one that is very old that Microsoft had on Channel 9 that I was actually going to go through here, but the audio wasn't coming through very well. So I'll share that on the Slack too. But it basically does the same where they're actually sitting in an office. The interviewee is actually on a real whiteboard, and then the interviewer in a mock interview is asking him the question. He's showing how he would actually do it on the whiteboard. So I'm going to share that too. But yeah, I mean, I think that's really what it is. It boils down to is practice. Make sure that you are as prepared as possible. Make sure that you are doing your basic refresh data structures algorithms, space-time complexity, all the base data structures that you think could be asked in an interview question. And when it comes to like design problems, those are also you're going to use for everything. The knowledge you're going to use is essentially the fundamental data structures and algorithms. and then your time complexity, right? So, and most of your early interviews are going to be, problem solving of this sort, and then some of your further interviews could be more around, how do you design Facebook, how do you do search, how do you write the find a friend function for Facebook. So you could get more and more complex problems. Cracking the coding interview is a great book. I would definitely recommend it. And it's good to just go through and even flip through, read the questions and read the answers, because that's going to give you ideas about how you can solve different problems. But yeah, I would say practice, do mock interviews. That's really the best way to ace the software engineering interviews, because they really are 80% of them are really just focused on your problem solving ability, your technical skills, and about 20% are going to be behavioral. Uh, what are your future aspirations? What are your weaknesses? How do you deal with conflict? So there's a lot of things we didn't cover. We didn't cover the 20% behavioral and all of those, but there's a lot of resources out there on that I can share as well. Um, but I really wanted to go deeper just into the whiteboarding part, because I think that's the part that gets a lot of people nervous. And that's the part that a lot of people who don't have experience with it don't know what to expect. So hopefully this short primer has given you an idea of what to expect. And, as we go through and we have another serious set of prep day coming up, we can go some more deeper into these. So thank you. Thanks everyone for joining. We're at time. I'll keep answering any questions that you have on Slack. So see you there. Thank you. Bye.